This is Dr.K.N.Sivabalan, and today's video lecture we will be learning about the role of parser. So parser is actually a significant and a vital component in the phases of compiler. So this is the graphical depiction about the role of the parser. The parser is actually connected with the lexical analyzer and the rest of the phases of the front end of the compiler. In lexical analyzer, we know that lexical analyzer is responsible for categorizing the source program into tokens, and it keeps the tokens, but it also supplies the token to the parser whenever it is required. So the parser, when it requests a token, it actually supplies the request to the lexical analyzer, and subsequently a token will be sent to the parser. So for every request, one token will be transferred to the parser. And a parser will be generating a parse tree, but to generate a parse tree, the parser will also ensure whether it is the tokens are adhering or complying to the rules of the language. The rules of the language is nothing but it is called as a context-free language. Now, if context-free grammar is actually, if the tokens are actually generated according to the context-free grammar and it actually follows the syntactic structure of the program, then obviously a parse tree will get generated. And parser, lexical analyzer, and the rest of the phases of the compiler actually have close association with the symbol table for referring the identifiers and constants. Now, the role of the parser is actually to scan the program from left to right, and it will ensure whether the tokens are actually generated according to the rules of the language. If it is actually adheres to the rules of the language, a parse tree will get generated. If not, actually it will throw an error message, and the error message will be handled by the error handler. The parser is also called as a syntax analyzer. So syntax analyzer and parser are synonymous to each other. Now, once the parse tree is getting generated, but the parse tree is actually getting generated in two major types. One is called as a top-down parsing, another is bottom-up parsing. Top-down parsing means we will start from the root node. And we will try to construct the parse tree from the root node to leaf node. So this is called as top-down parsing. And here we will also learn about the leftmost derivation. So leftmost derivation means we try to replace the leftmost non-terminal for expansion. So in this case, I have applied a grammar S tends to ABD. So we can see here the leftmost non-terminal is A. So A is getting abbreviated as expanded as small a capital A with the production called as A tends to small. So small a capital A. And now the leftmost non-terminal is called as A. A is actually getting replaced by small a. So it is replaced by small a now. Now we are left with two non-terminals called as B and D. So in that leftmost non-terminal is B. So B is getting abbreviated as B, small b. So AAB, and finally we are left with only one non-terminal called as D. So we expand D. So D will be expanded as small d. So small d is getting replaced by small d. So we are having AABD as a string. So this concept is called as leftmost derivation. And when you go for bottom-up parsing, the bottom-up parsing is actually we try to construct a tree from the leaf node. So here we start from the leaf node and we try to construct towards the root node. So if you are constructing a parse tree from leaf node to root node, then obviously that is called as bottom-up parsing. So rightmost derivation is actually the vice versa of leftmost derivation. So we are doing the leftmost derivation in a different format. That means instead of replacing the leftmost non-terminal, if you are replacing the rightmost non-terminal, then that is called as the rightmost derivation. So here an example has been illustrated. So S tends to ABD. So in that D is actually called as the rightmost non-terminal. So D is getting replaced here with the help of D tends to small d. Then we are left with two most non-terminals here, A, B. So B is getting replaced by B. So there is a small change here. B should be replaced by small b. So I have represented as D here. So this is wrong. So B will be replaced by small b. Now when we move on the right, actually we have another non-terminal called as A. A tends to small a. So A is actually replaced by small a, capital A. Now when we move from the right towards the left, you can see that only one non-terminal is there, so A is getting replaced by small a, so you will get an answer called as AABD. So this is called as rightmost derivation. Now we go for bottom-up parsing. Bottom-up parsing, you will be learning about handle pruning and reduction. So I take up a grammar S tends to AB, A tends to small a, B tends to small b. Now in this, when I have a string called as AABB, this small a can be replaced by A, isn't it? So now this small a has a protection, whereas it can be replaced by capital A. So this two small a's is called as handle, and similarly this two small b's is also called as handle because two b's can also be replaced by capital B. So these two b's are also called as handle. Now reducing the handle with the non-terminal is called as handle pruning. Now what you can do is this small a can be replaced by capital A. So I replace it by capital A. This concept is called as handle pruning. Now bottom-up parsing generally reads the characters from left to right, and the parsing is done in a fashion of a rightmost derivation and reverse. Now we'll learn about this handle pruning and handle reduction. Now let us take the string called as AABD. Now when we move on the one step on the right, A can be replaced by small a, capital A. So now this A is called as a handle. Now if I replace the second A by capital A, you will get small a, capital A. Now this small a, capital A has a protection, whereas small a, capital A can be replaced by capital A. So small a and capital A is called as a handle. So I take this protection A tends to small a, capital A. So small a, capital A is replaced by capital A now. So what is remaining? B and D. When I move on the right, B is there. So is there any protection for B? Yes, B tends to capital B tends to small b. So B is called as a handle. So when I apply this, replace the small b by capital B, I will get A, B and small d. Now when we move on the right, D is also a protection. D, so D can be replaced by capital D. So now ABD, you get an answer now. So ABD can be replaced by S, that's called as a protection here. So it can be reduced to S, so ABD is called as a handle. So when I replace this ABD by S, so you finally get called as S here. So we actually take up a sentential form from small leaf nodes, and we try to construct towards the leaf node. We try to construct towards the root node. So this concept is called as bottom-up parsing. Now there are two different types of parsing, broadly classified into two types. One is top-down parsers and another is bottom-up parsers. Top-down parsers is classified as with backtracking and without backtracking. So with backtracking we have brute forcing. With backtracking means to derive a particular string, you apply one specific character, and you find that that character is not obviously going to derive the string. So instead of that, you apply a new character. So this concept is called as backtracking. So it is actually happened on the trial and error basis. Now without backtracking means you don't do such a process. Once you apply an input, then you won't backtrack. So that is called as without backtracking. So there are two types of backtracking. Without backtracking, that is recursive descent parsing, and another called as predictive parsing. LL1. Predictive parsing is also called as LL1 parsing or LLK parsing. Now in bottom-up parsing, you have operator precedence parsing and LR parsing. And LR parser is classified as three types: SLR parsing, that is called as simple LR parsing. Then CLR is called as canonical LR parsing, and LALR is called as look-ahead LR parsing. So that's about the role of the parser and the types of parsing. So thanks for watching the video. Have a good day.